Assalamualaikum semua. Boleh dengar? Boleh ke?
Okay.
Okay. Sorry what do you call it? Saya kena aircon still rosak. This semester makin banyak sangat kali lah. Kita tunggu about 5 minutes more before kita start. Okay, so basically everyone is here. So we today, like our previous punya class, we're going to do some lecture first, and then we're going to do with your module that you guys have prepared from last week. Okay, so today we're going to start with our multi-machine punya. This will be our second last punya topic kan. There's one more topic, and then we're going to do tutorial for our final exam. So this will be your second last chapter. So let's start with talking about distributed computing. So before this, we have done coding for sequential, then multiprocessing, multi-threading, pakai GPU, and now it's multi-machine. Okay, so multi-machine is where we ask several computer to finish one job. Okay, so you can see the job is a combination of multiple tasks. Okay, so these are the reference. So the point, okay, the most important point for distributed computing is two factors. One is how you divide the task. So you have one big job, and how you divide the task between the computer. And third of all is how you scale. How do you move from a code that execute in one computer to two computer to three computer to 100 computer? It's about scaling. When you talk about scaling, you also have to think about synchronization or between the computer, how data is transferred between the computer and so on. Okay, so it becomes more complicated as you grow your code to a multi-machine punya way. Okay, so let's look at this problem. Okay, so you have, if we take the example from astrophysics. So let's say you have 800 terabyte of data. Okay, you have 800 terabyte of data, and you need to do several things with data. First, you need to analyze. It's a very intensive computing. To process all 800 terabyte of data, you need 40 processors. Okay, not talking about GPU processor, we're talking about CPU processor, 40 processor. So if we take that each computer has about 8 processor, so 8 core, sorry. So you will need at least 5 computer, isn't it? Then after you have done your process, you need to archive a result. Okay, so there are at least 3 things you have to have. First, the data itself, the redundancy of that data. If the data is failed, the delete, you have a backup data. And then third is the output, the analyzed data. So you have 3 different volume of data. So the question is, do you think it can be done in a single machine? Okay. So raise up your hand. Okay, raise me. If you think that this can be done, okay, this can be done with a single machine. Do you think this can be possible with a single machine? Anyone think it is possible? Okay, since the silence, I take that everyone's agree that this kind of job cannot be done in a single machine. Okay, even if our computer right now has about 64 processor. Okay, yes, you can do all the analysis in a single machine. However, to store all this data, okay, remember you have 3 volume of data, 3 type of data: the raw data, the analyzed data, and the backup data. So you cannot have all 3 in the same machine. If anything happened to that one single machine, all your data is lost. So the redundancy, the security of data require for it to be multiple. Okay, so we have discovered several factors with problem with isolated system. So these are what we call it the problem. Sorry, the problem with isolated system in a single machine. First, so I want everyone to key in to type what do you guys think are the problem with doing everything in a single machine. Okay, for example, you can say that if anything happened to that laptop, to the machine, all your analysis and data will be gone, right? If you don't use cloud backup lah. So what are the thing that is difficult when you're doing all your job, okay, all your tasks in a single machine? Anyone want to key in to chat? You can put it on the chat. What are some kind of problem when you are using a single machine punya data? When you're doing all your job in a single machine? Okay. Can anyone? Yes. Yep. Third, overload the RAM, completely true. Yep. In the RAM process. So, yep, impossible to isolate system. Good. So when you Saya nak buat yang baru, yang satu yang baru. So you guys can chip in. Mana ni? Okay. So problem with isolated machine, single machine. Macam yang tadi, problem with limited resource. Okay. So we are talking macam tadi, not enough RAM, okay, not enough RAM, not enough enough process, which make job slower to process. Okay, and then someone say about tadi impossible to properly isolate the system. Correct. Okay, this one is about security. Okay, impossible to isolate. So when you work in a very big job in big science, it's very common for you guys have to do what you call it. Several people are doing the same project. So you want to have some kind of isolation, okay, in terms of security, supaya there's no data breach, tak ada one poison the data and so on. Okay, what are other things you guys can think of? What are other problems that you think of can make is the what do you call it? The problem with isolated system. Anyone? Anyone has any more input? Ada dua lagi. Technical challenges, not quite. The overheating is under resources, limited resources. So the problem, kalau you tengok a lot of university, not a lot of university, yeah, a lot of research lab, you see, they have less and less their own computer lab ataupun their own server. Okay, less and less are using their own isolated server. The problem with having your own server and your own lab is that most of the time actually your computer tak terpakai. No one is using your lab, server lab masa malam and so on. So it's therefore it lacks efficiency ataupun because no one is using that machine, that computer all the time. Okay, so when you have a single machine, it's very hard to share resources. Okay, this also about the panggil transparency. Okay, of resource available. So the good thing, for example, right now, when you have katakanlah kita kumpulkan all the computer and then you give access to the computer 24/7. So anyone can use this computer at any time. They don't physically have to be inside the lab or inside their lab lah. They can access online, and then who is using your resource, who is using, what are they running, can be known. Kita tak perlu nampak secara detail, tapi kita tahu bahawa okay, si Alex tengah pakai 4 core, si Sufi tengah pakai 7 core. We can see that. So when you do an isolated system, it's hard to do that. Okay, and last of all, yang paling penting actually is scaling, both up and down. So when you have isolated, it's fixed. The amount of resources that you have fixed. If you nak upgrade the resources, it's very hard. Okay, you kena order RAM, kena tambah. Even itu pun kalau you punya laptop ataupun komputer boleh di upgrade. Most of the laptop and computer right now cannot be upgraded. So it's very hard for you to scale up or scale down. Okay, scale up means that whenever you need a high resources, then you bayar sekejap, then you get a powerful GPU ke, a more RAM ke. The scale down is when you dah habis your experiment, you finish your task, then you delete. And then you tak payah bayar apa-apa dah. For gamers, it's similar to kalau you guys pernah dengar NVIDIA Cloud Run, something like that. So you have access to play games on the cloud using NVIDIA punya GPU without you have to buy a GPU for yourself. And you only have to pay NVIDIA when you actually want to play the games. So sometimes if you have to use, usually when you do experiment, isn't it? You start with buat abstract semua. In the middle baru you buat running the experiment, and that's when you actually want to use high computer, and then actually you bayar cloud services untuk access the computing resources. Sebelum tu you tak bayar. So when you have the ability to scale up and scale down, it makes your nak bayar tu lebih murah, sebab you only pay when you actually want to use it. Okay, so that are several problems with isolated machine. Okay, so these are the objective. Okay, when you want to do a distributed system, okay, these are the objective. First is resource accessibility. Means that when you gather all of this machine, we are not talking one computer, 3, 4, 500 computer at one point. You bagi tahu, okay, people can access this computer, and who can access it, what time they can access it, how much resources that you can use. Okay, that is resource accessibility. Means that people can use this machine when they want to. Okay, system transparency, like I said, you how much resource is available right now. You know who are the people yang tengah pakai the resources. You know how much resources that is still your quota, and so on. There's transparency on who is using the resources right now. System openness is that your system is not rigid. Means that you can run many experiment, many analysis inside the computer. Okay, some people use Python to write their code. Some people use C or C++ to write the code. Some using okay, anyone can run their analysis on that computer. Okay, in system scalability, as I said, that the system is easy for you guys to scale up and scale down. Okay, you only use it when you only use it, or you only pay when you really want to use the resources. Okay, kalau you buy a computer, once you buy it, it's there. Even if you tak guna pun, it's there. So right, and after 5 years, tak kisahlah you pakai ke tak, dia akan rosak. Macam tu lah. Okay. So characteristic of distributed system. First, there's no common physical lock. Means that usually each computer has their own clock. There's no global clock. is geographically separated. Ni kalau you punya cluster is besar lah. Autonomy and heterogeneity. Autonomy ni kalau we have talking about several cluster combining, but the more important is heterogeneity. Heterogeneity means that the hardware of the computer inside that system, inside that cluster computer. We have computer with GPU, with computer non-GPU. So it's heterogeneous. You can mix and match inside your system. And lastly, usually no shared memory. Means every process, every task is independent their memory of one another. This one is because of security. All right. Benefit naturally better scalability, performance over price, and high availability. Performance over price ni is because when you macam tadi when you use cloud computing atau tu, you only pay when you using it. Okay, and then there's also the cost of maintenance. So if you are outsourcing, okay, a lot of your computer pakai dekat Google Cloud Computing atau Amazon, you don't really have to pay maintenance to it. Amazon dengan Google yang akan maintain the computing resources. Okay, so that is the price lah, lagi murah. Okay, alright, let's talk about type of different distributed system. Okay, we talk about, okay, this is what we call the Flink's taxonomy. Okay, so you have single instruction, single data stream. So these are CPU, which has only single instruction and single data stream. You have single instruction, multiple data stream. So this is your GPU, single instruction with multiple data stream with data parallelism. Okay, multiple instruction, single data stream tak wujud. Well, rare. I tak pernah jumpa lagi. And all GPU right now is multiple instruction and multiple data stream. Okay, MIMD. So our computer now is here. Okay, this is our computer. So let's start with vector machine. When you hear supercomputer, okay, so dengar supercomputer semua, actually what it means is actually vector machine. Okay, vector machine ni is single instruction, multiple data stream. Okay, is the grandfather of GPU. So a lot of supercomputer doesn't exist anymore. So the design of vector machine or supercomputer is that these are big computers, large computer, but it can only do one function. So usually at the start, for example, this computer is for war, untuk perang. So it can only do macam tactical, something like that. It's very specialized. This supercomputer is to manage stock market. So it's only going to do manage stock market. It's specialized. Also, the famous supercomputer is for example, for weather forecasting. So these are all single instruction, single instruction, multiple data. So they are collecting vast amount of data and then execute it one single job. Okay, because of this computer is very specialized. Okay, they are optimized to do one job. Usually it's very expensive. They don't use the same hardware that our computer use, and therefore it's already deprecated. As far as I know, there's no real supercomputer in operation right now. Okay, now the difference between kita panggil apa nama dia, your machine right now, your computer right now is a general purpose computer. Okay, your computer can do a lot of things, playing game, working document, words. It can go from predicting a war to playing game to looking at Netflix. So it's general purpose. Okay, and a lot of computing are designed in that way. Okay, it can do multiple things. It can do multiple jobs. Okay, so here comes the Beowulf cluster. Okay, all computer cluster, grid computing, cloud computing, all this to start from this. This is the grandfather of it, the Beowulf cluster. It was developed by NASA in 1924. Okay, it used multiple computer code nodes and connected via LAN, local area network. Okay, yang kabel warna kuning with paling besar tu. Okay, the most important characteristic. Okay, it is use commodity hardware. Commodity hardware means that hardware yang you boleh beli dekat Amazon ke, dekat Loyat ke, dekat Shopee ke, is commodity. Everyone has access to this kind of hardware. Okay, so if you have enough money, or some people they build their first Beowulf cluster using pakai several Arduino or several Raspberry Pi. They beli 3 and they combine, it jadi a mini cluster. You can do that. You can create your first Beowulf cluster. Okay, so heterogeneity is welcome. You can mix and match a lot of things, but the more heterogeneous your system, the more downgrade your performance is. Because in a cluster, okay, if you have several computers, the baseline will be the computer with the lowest resources. So katakanlah you have several computers that is connected to your cluster, and one of the computer has only 4 core. Yang lain semua ada 8 core. This one single computer has 4 core. So the baseline of that cluster right now is 4 core, because they always have to follow the most minimum. Okay, so the baseline, if you want to start, you will be start with 4 core, and a lot of the other pun dia akan by default akan guna 4 core juga. Okay, and it is managed by something we call middleware, and most of this middleware is open source. Instead, anyone can use it. Okay, so these are diagram of Beowulf cluster. So you have several machine. Each machine is called a node. Okay, there are 2 types of nodes. Ada basic you punya guys punya tahap ada 2. Satu master node which control all other, and the computing node. The computing node sometimes also kita panggil the client node, the worker node, and so on. Okay, so the master node is the one who give job to the computing node, give task to the computing node, so the computing node can execute it. Okay, see that each computer has its own OS. It works independently. It can do job independently. It can do tasks independently. Okay, so if one of these node is offline or apa-apa, the other node is still available. You can use it. Okay, so these are the implementation of a Beowulf cluster. So your code, your Python code is here. Okay, it must be translated into a parallel programming environment, a distributed environment, and the code akan cakap with the middleware. The middleware will talk to the hardware. Means everyone is connected by a high-speed network switch, a LAN basically. Okay, so that is computer cluster. Okay, a computer cluster tend to be local, means that in a single building or single room, so you have several computers fixed together to become a one computer cluster. Okay, now if you connect several computer cluster, for example, these are several computer cluster, you connect between the cluster, it becomes a computer grid. Okay, a grid computing is where you basically connect several computer clusters together so that you can run more bigger job. Okay, this usually we are talking about a very big job. So for example, simulating climate change, very big physics job, very big DNA sequencing, very big astrophysics that cannot be done just using one computer cluster. For example, the recent one is when they want to take picture of the what we call it, take picture of the black hole. Okay, the black hole punya gambar tu, I think if I remember correctly, it has to connect to 3-4 computer cluster around the globe to combine the picture. Okay, so that are some application of grid computing. But grid computing ni, it used to be very popular before the rise of cloud computing. Okay, now actually grid computing is a bit out of the science. Not a lot of people are using grid computing. Okay, people are slowly moving to cloud computing. Okay, if you feel like macam sekarang macam terawang-awang, tak apa. Next one, kita punya next class, we do hands-on how to do cloud computing. Okay, so here is the basic of cloud computing is what we call encapsulation. Okay, this you can think encapsulation is when you have one machine. You have one machine, satu komputer, and dalam komputer tu ada several operating system, several OS. So let's say for example that machine ada 16 core. Okay, 16 core besar server. So 4 core, you buat satu virtual computer. So this virtual computer akan ambil 4 core. And another virtual computer akan ambil 8 core. And another virtual computer ambil another 6 core. Okay. So in that one machine, actually ada 3 computer, ada 3 virtual OS. Okay. I'm very simplifying here. So this setiap virtual computer tu is independent of one another. Okay. So this is something like hosting lah. So one machine can be shared among many other people. So because when you have virtual computer, each computer thinks it is a one physical computer. Okay, it thinks one physical computer, and you cannot, between this computer, there's no connection. You have to make a, kita panggil virtual network between this computer. Okay, so these are right now the fundamental of all your cloud computing from Google CA, Amazon, and also Azure. The newest one is Alibaba. So this is what we call the infrastructure as a service. Okay, so you can basically create order. Okay, you can create virtual computer. Let me share with you so it become easy for you guys to understand. Okay. So for example here, okay. So for example here, this is another service, DigitalOcean. Okay, it's similar like Google Cloud Computing. So it's just another cloud computing provider. So here, your kenang alert yang one yang USSH sebelum ni semua ni, it is server exists virtually. It's not like it's not like a physical server. Okay, the DigitalOcean RAN, okay, dia sewakan kat 2 virtual computer, 2 gig of RAM and 50 gig of disk. When you interact with this server, it feels like a physical server. The server itself does not know it is a virtual, it is running on a virtual hardware, okay, we call it. So when you have something like this, okay, it's very easy for it to be scaled up or scaled down. Ni. Okay. So macam sekarang I pakai 2 CPU. If I want to upgrade it, okay, I can upgrade up to sampai 8 core. Okay, so you will feel like your work is faster and everything is faster. So this is what I mean by it is easy to scale up or scale down. You can go to 1 virtual computer up to 8 computer, and if you pick one, dia akan jadi lagi murah lah. Okay, so this is basically computing. Okay, so let's say you want to have tak ada GPU buat yang lain. Okay, so these are example of tu cloud computing. Okay, so you are renting out, okay, renting out server, virtual server, or you can rent a physical server if you want, but it's much more expensive. Okay, so it allows you to use the computer, use the resources whenever you want it. Okay, if you are running an experiment and tiba-tiba eksperimen tu perlukan 32 core, you can just rent it. Bayarlah about 100 or 200. It's cheaper than buying a new hardware terus. The new hardware can go up to 20,000, 30,000, and then you want to do your experiment for just couple of weeks. So it's mubazir. It's much cheaper if you just rent a virtual hardware infrastructure service and just pay a bit. Okay, so before I continue, anyone has a question? Okay, ada. So I'm going to go this fastly, quickly, before we go for part 2. So a lot of people think when you do supercomputer, cluster computer, grade computer, cloud computer, it's about hardware. No, a lot of Malaysians, especially admin, they are obsessed about hardware. The hardware, kalau you beli 10 komputer, you letak dalam satu bilik, dia tak jadi komputer cluster. You buy 10 different machine, big machine, then you just buy and put it in a room, you connect all the wire and everything, it will not become a computer cluster. What makes several machines a computer cluster is the software. It's the software that allows this computer to work together, to combine, to talk to each other. And this software, what we call as middleware. There are a lot of other, this is where system architecture comes in. Okay, system architecture is one of the most job yang paling mahal dalam dunia. So the starting of system architecture can be easily 7,000, 8,000 ringgit Malaysia, and a senior of system architecture can easily go to 20,000. because they have to think big. They have to think about the system, the whole computing system. And usually system architecture is 24/7. Anything, anytime the system is down, the system architecture has to be on call. Okay, that's why it's very, their job is expensive. So you have several kind of software that is required for you guys to make a computer cluster. Okay, so these are several. Puppet is for orchestration. Camlia is for monitoring. HT Condor for job scheduling. Slurm is also for scheduling. OpenStack is for creating virtualization. Okay, so that's it. So we're going to talk after this about computer network pula. Remember, computer network is the basic. Without the computer network, your computer cannot connect to each other. Okay, so let's take about 10-minute break. Okay, and then we continue talking about the computer network pula. Okay, if you have any question, just you can drop your question in the chat box. Alright. Assalamualaikum warahmatullahi wabarakatuh. So to answer Akil punya question, yes, usually that is the current way of developing any kind of application, software and so on. Okay, so usually you will use your computer locally to develop software. Okay, to develop the application, the code, the software you are ever developed, and then when you want to actually run it, okay, if your job require a GPU, if your job require a lot of core, you will run it on server. You will rent kita panggil a cloud server, okay. You run a cloud server, you set up the cloud server to have several CPU. Require lah, you nak berapa banyak CPU, berapa banyak RAM. And then once you punya virtual server is dah sedia, it's ready, you can run your code. Okay, and when you run, you left it, you akan run until your job is finished. And then once you job is finished, you take the output and you delete the virtual server. Selagi you tak delete the virtual server, selagi tu you kena bayar. Okay, so that's how usually people do it nowadays. For me lah. Okay, so actually, whenever you use a Google Colab, Google Colab, each time you open a Google Colab, actually it opens a virtual instance, okay, of a virtual server. A virtual server with 2 CPU at its core. And also, kalau you pakai GPU, dia akan, itulah. So each time you open a Google Colab, actually is opening a one virtual server. That's why there's Google Colab, dia tak bercampur. It doesn't connect with anybody else. Okay, your collab is your collab until you share it lah. Okay, so that's how you do it. If I may share, for example, to show you that actually it's a what we call it, a server. So this is your Google Colab yang saya pakai. Next. Next thing ni actually is trying to spinning up itu. So by Google compute backend. So actually is so to show you this is for example. See, so this when you put a tanda seru tu, actually is a command, macam terminal command yang you pakai kat CMD or something like that. It's a command. So for example, when I do fconfig, so this is the network config behind this server. So whenever you actually run, okay, actually Google are giving you a one small virtual server. Okay, so yeah, and technically if you pandai, you can open many Google collaboratory and then you connect it, dia jadi macam a virtual cluster. You can do it if you want, but it's complicated. Okay, other thing, for example, top. Tadi bagi ada, see. So it is running all this is the macam task manager yang tengah berlaku dekat apa dalam the virtual computer. Okay. Dan tak boleh buat banyak, nanti Google marah. Okay. Alright. Back to our lecture. So if you want to do this kind of system architecture connecting several creating all of this virtual cluster, and then cloud computing and everything like this, you have to have a very strong foundation on network. Okay, and network engineer, network architecture is the one of the most sought after. Okay, and tak kisahlah, tak kisah what any of computer trend yang berlaku lepas ni. So right now we are living in AI bubble. Sebelum ni is a data scientist punya bubble. Sebelum that is machine learning. Sebelum that is what we call it, Bitcoin. Almost every 1 or 2 years there's going to be a new computing punya trend. But in any trend, the network guy, the network people yang manage the network usually still one of the highest paying job, because network is crazily difficult. Okay, because you have to do a lot of things. You are basically managing the highway of your data. Yeah, so it's very complicated. Okay, so if anyone who wants to do big money, you can go into network. Okay, you don't need to have a degree in computer science degree. No, you can belajar on your own, you can read on your own, you can learn on your own, and then you get a certificate from Cisco, maybe exam from Cisco, from Microsoft, apa ke, something like that. Once you have your certificate, you're eligible to become a network engineer, and then you get your money. Okay, so the trinity of computer. Okay, when you do computer, you cannot run from these three things: CPU, memory, and I/O. Okay, input output. So now we're talking about I/O. So you can imagine the networking is basically CPU trying to communicate with other CPU. Okay, CPU trying to communicate with CPU. When you are connected to internet, your laptop CPU is talking to another CPU via the network and the computer. Okay, so you are just CPU talking to another CPU. When you are doing multi-processing, okay, so you are one core CPU talking to another core, one core to another core, with the intermediary is your RAM or your GPU. Sorry, this is multi-processing. This is GPU, and for local area network, okay, one CPU talking to another CPU using the local area network. Okay, it's just different CPU messaging to another CPU. Okay, so all this networking is how to build the network, how to each CPU talk to another CPU. So the most easiest, there are many kind of framework. Framework, there are client server model, there are WebSocket, there are a lot of, okay. But the most important is what we call the client server architecture. Okay. So this is where the 95, I would say 80% of 75% of internet is built by this architecture, the client server architecture. You have your Google punya server, you punya Instagram punya server, YouTube punya server. What happened is that, let's say you open YouTube, the first thing is your computer or your handphone try to do a connection request to a YouTube server. YouTube cakap balik, okay, kita dah connect, lepas tu you send a request, okay, request a video, and then the server reply and then give another video back. So these are the client server. Okay, these are the client server architecture. It's just client talking to server, server hantar balik, client hantar balik, server hantar balik. Okay. Alright. So in a distributed computing, the computer is one you want to connect all of this. Okay. For example, this is a client. You want to talk to the computer cluster, to the computer grid. You want to talk to your sensor, and sometimes you want to do machine learning ke AI ke, to talk to some kind of analytical background. Okay, so from your laptop you can do a lot of things if you know how to connect with it. to know how to play with the API and so on. Okay, so these are the layer internet. There are 7 layers on internet, and some book is 13. Okay, I'm not going to address each layer. I'm going to say to you only what is relevant to you. As a physicist, as someone who wants to build an apps, these are the 3 layers that you must know. First is your application layer. This is your SSH, SCP, FTP, HTTP, your Safari, your web browser, anything that involve application. Okay, this is the transport layer. Is how your data travel to what protocol that your data use to travel towards the internet. And lastly is the network. Okay, network layer. So let's talk about starting from the physical dulu. So the physical layer is that you have to understand these 3 things. The difference between router, switch, and a modem. Okay, so most of home you have this, unified, and then atas ni there's a router, usually at home. Okay, so in some country, not Malaysia, in some country they combine modem and router. Okay, they combine modem and router, and people usually confuse between these 3 things. Okay, can I raise up? Can for all students, try to raise your hand. Okay, if any of you guys are confused between these 3 things. Siapa yang confused between these 3 things yang you jumpa kat rumah? Okay, yep. So this even if you pergi you punya, okay, thank you. So most of people are confused between all of these 3 hardware. Okay, so the first thing you have to know is modem. Modem right now as is your life support system. Without modem, you tak ada internet. Without modem, you tak ada internet. The most important thing about modem is that it converts signal into some kind of physical tone. Okay, for example, okay, so a modem is the thing that you take data is still in electrical signal, and it convert into something that is physical. For example, paling senang is your fiber optic modem. So usually you find at home is this one, Unify or Time or Maxis or whatever. So it convert your electrical signal into a optic signal. It converts the medium. Faham tak? Because your internet runs on fiber optic, right? Fiber optic. So there's something that required from being a electrical signal, convert into optic signal, and that job is your modem. Modem ni, it convert from one electrical signal, the usual, into another signal. There are many type of modem. For example, some, kalau the one that we're using, the most popular is fiber optic modem. So the fiber optic input is a electrical signal. Okay, yang kabel warna kabel telefon with paling besar tu. And then the output you see a very fiber yang nipis. Okay, that's the fiber. So it can convert the electrical signal into an optic. In some country, for example, in Australia, they don't use fiber optic. They use electrical cable, TNB. So this internet is provided with the TNB, TNB copper lagi tu. Dalam TNB tu ada internet. So that TNB signal, that TNB punya wire give power and also internet. That one is electrical signal with electrical signal, but the frequency is berbeza because the frequency of that modem have to convert into the frequency yang tak kacau the TNB punya signal. If you if you get what I mean. In rural area, rural area, contohnya, what do you call it? Satellite. Okay, some people just Starlink. So you need to modem that convert from nuclear signal into electromagnetic wave radio. Okay, that can connect to a what do you call it, to a satellite. So that's their modem. So modem is something that converts into a medium. You can see your phone is a modem. That's why your modem, your handphone can do a hotspot. Okay, so macam tu lah. It converts into a signaling punya system. Okay, now a router yang you jumpa, yang selalu usually orang letak atas modem tu, yang ada banyak antena macam ni. Okay, the modern term is Wi-Fi router, right? But you, okay, macam tu. A router can be have Wi-Fi or not Wi-Fi, but usually it's a Wi-Fi. Antenna tu is for the Wi-Fi. A router is a route. Route itulah router lah, jalan. Okay. The tugas router is to know where to send your information, where to get your information. Let's say you want to connect with YouTube. Okay, it's your router's job to know, to have the map of the internet. Okay, from here I will connect, the router cakap, okay, connect to Unify punya center. From Unify akan connect kepada Google akan connect kepada YouTube. So the router tu, it provide the packaging signal where to go. Okay, go here and then go here and then go here and then go here. So that's router. Router ni dia route the signal. Okay, modem convert, router dia bagi tahu kat mana nak pergi, where to go. And you have to know that your data, there's usually people do multiple routing. So even though you nak pergi the same destination, for example Instagram, your data will be split into many packages and these packages will go different routes. Okay, dia macam tu. So the router ni dia pecahkan, dia bagi tahu, okay, router data ni lalu jalan ni, data ni lalu jalan ni, dia pergi sana and then dia dapat balik, dia unpackage. So that's a router. A switch does not connect to the internet. A switch does not connect to the internet. A switch is to create local area network. So you have several computers, and there's this computer, you nak connect to it, then you connect to a switch. Okay, with switch you cannot connect to the internet unless if your switch need connect to a router. If your switch on its own, it cannot connect to the internet. It's just there to connect with a lot of computers serentak, okay, to create a local area network. So sometimes when you go to a computer store and you tengok benda ni macam router, bentuk dia macam router, tapi dia sangat murah. Basically, usually there is a switch, not a router. Okay. All right. Let's try to figure out. Okay. I want you guys to really look at this figure and try to figure out if which machine is which machine, which symbol, which one is a router, which one is a switch, and which one is a modem. Okay. I give you guys 5 minutes to figure out ni router ke modem ke switch. Which one is which? Okay, dah tahu? So you can write your answer in the chat box. Okay. You guys think this is what? A router, a modem, or the switch? This one. Yes, it is a router. Okay. As you can see, router, they connect to one another. Okay. Router. Okay. So that's a router. Correct. So this one will be a router ke a switch. You can see here. Yep, it's a switch. Okay. See, the switch is connected to the router. And this one is also connected to the router. And this also a Wi-Fi router. Therefore, this one is a modem. Okay. Because you can see the modem, see, nampak, they connect to the TNB punya line. So this is a modem. So yes, everyone tu. Okay. Good. Okay, semua orang dah faham. So let's talk about the network layer. Okay, let's start with the IP address. So there are IP address is how your computer connect to one another. It's your address in the internet. Right now, there's two kind of IP address, the IP version 4 and IP version 6. We are still using a lot of IP version 4, but in the coming to, people are slowly migrating to IP version 6. Okay, so the what do you call it? IP address has 4 numbers, and between the numbers there's dot. Okay, 4 number. Okay, so the 4 number, okay, it can go from 0 to 255. Number 255 because it's in the 2. 2, 8, 16, 32, 64, 128, 128, 256. Okay, 256. Number 255 because dia bergerak daripada kosong. Okay, so in the total, dia ada 25. Okay, so these are all the combination. You can use any kind of IP number. However, there are several IP address that is kita panggil special. Okay, special IP address. Okay, we will go through this one by one. Okay. So the first IP address, okay, 12701 ni is for kita panggil local IP address for home address. Okay, so this is your default. Macam if you are if for example you have two application and another two application that want to access one another, dia pakai IP address ni. Dia bagi tahu 127 ni bagi tahu bahawa this we are connecting locally dalam satu komputer je. Okay, anyone else tak boleh connect to this IP address. This IP address is for your computer. Okay, it's the home IP address, local IP address. Okay, so even kalau you say local host translate into this IP address. Okay, now 0000 ni is IP address yang terbuka kepada sesiapa. If you are developing an application and you set your application to 000, means that anyone can connect to your application. Everyone. Okay, everyone can connect to your application. So if you macam tu lah. So anyone can connect to you. Okay, 000. Now 10.01 and 192.168 ni is kita panggil dia your IP address dalam dalam your what I call it, dalam your sub network ataupun you punya own network. Okay. Kalau 10.0.0 ni is your IP address dalam satu organisasi besar, big organization. You usually start with 10.0.1. So whenever your IP address start with 010 ni, it tells your computer that you are connecting to a large network punya organization. Okay. So if you check your IP address right now, your Wi-Fi, you connect to your, you right click to your Wi-Fi, and then you tengok you punya IP address, it start with 010 because you are connecting to the IP address of your Wi-Fi, IIM IP address. Okay. If you balik rumah, you go back your home or you connect to a hotspot, your IP address will start as this one, 192.168. Okay. So this tells you, the computer that you are connecting to a small local network. So you can, if there's another computer in your local area network, that computer can trust that computer because it's the same local trusted punya network lah. Okay. This allow your computer to connect with your TV, to connect your phone. Okay, so that is what we call a local IP address. 255 and to me this is a subnet. Subnet mask is a configuration. What I'm telling you, just jangan pakai IP address ni. Do not pakai any IP address that start with 255. This is a technical configuration. Okay, and 888 and 844 is Google punya IP address, Google DNS punya IP address. Okay. Now let's talk about DNS. So if you guys, so now you get lah. There's no place like 127.0.1 ni is home, no place like home. Okay. So DNS, this is the most important thing on the internet. Okay. If when people say they want to delete the internet, what they mean is they want to delete the DNS. There is a physical button that can delete the internet. Dekat apa, tak ingat nama tempat tu. Once you delete the DNS, the physical DNS, no one can connect to another one. Okay. So the DNS is the yellow page of the internet. Okay. It tells you where to go. So for example, let me open. Okay. Let me share my, can you see? Okay. For example, tadi I tunjuk config ni is untuk Linux and tu is their internet configuration. So this is all the tu nampak pula. So right now, because I'm connecting with my home punya Wi-Fi, my IP address is ni. Okay. This is my IP address right now. Okay. 192.168. So when you have this IP address, it tells the computer that you are behind a router. Okay. So actually, another server, another one cannot really access my computer directly. It's for security system. Anyway, so here, for example, the host of Google punya IP address. Okay, so this is Google punya IP address right now. 172. So this is Google punya IP address. This is IP, so IP Internet Protocol 4, and this is IP version 6. Okay, so another one, for example, is Instagram. Okay, this is Instagram punya IP address. The thing about IP address, you can change it. Okay, you can change it. You can is this Instagram punya apa IP address. Sorry, this is what we call the URL address. The address is fixed, but it can be directed to any particular IP address. You do that. Sometimes, what we call it, company do that to change the server, to do system maintenance. They change the IP address. Okay, so to track, to keep record. Okay, Google sekarang pakai IP address mana? Unify pakai address apa? Instagram pakai IP address apa? That is the job of DNS. DNS apa tengok nama dia? What is DNS? DNS punya domain name server. Okay, domain name server. Okay, so it translates the domain, which is domain name. Google.com is a domain name. Instagram.com is a domain. It translates into an IP address. Without this translation, you cannot connect. Okay, so for example, if I took this IP address, okay, copy, then I buka a new one. Okay, so this is a two. If you look here, window. Okay, so you can nampak the URL. So if I put this, okay, I letak the IP address, dia akan bawa ke Google. Because I give the IP address and it will translate to Google. So right now I'm posting 157. Okay. Later I'm not posting Instagram.com, but I'm posting the IP address from Instagram. Dia akan bawa ke mana? Dia bagi tahu lah. Dia bawa ke Facebook. Because Instagram bawa Facebook. Betul tu? Okay. So that's the DNS. Okay. So the what do you call it? The job of DNS, okay, is to translate the domain name into the IP address. If the translation doesn't happen, router tak tahu nak ikut mana. Okay, and for a lot of government, not UIA, tak kisahlah, government ke, they usually akan terpanggil, if they want to block a website, they delete, they disallow the translation of that domain into an IP address. Okay, so macam kalau you nak, for example, tiba-tiba Google Malaysia nak ban Instagram, so the way they do it, they delete the translation. They don't allow from people to translate Instagram to the IP address. When the translation cannot happen, so you cannot connect to Instagram. Okay, of course there are many ways to bypass this. Okay, so in UIA make a very important rule that if you want to use UIA punya network, you must connect with UIA punya domain punya server. Kalau you pakai any other domain server, UIA akan disconnect you from the internet. Dia tak bagi. Betul lah. Okay. So to DNS. Alright. Next. So can anyone tell me why this configuration is wrong? Anyone can tell me why this configuration is wrong? Boleh letak dekat dalam chat box. Anyone? Tak tahu. Okay. Remember the function of DNS server. The function of DNS server is translate your domain kepada you punya IP address. Okay, when you set your domain name server punya IP address as 127.1, you are trying bagi tahu dekat komputer translate pakai your own laptop. So 127.1 is your local IP address. Okay, you are asking yourself, the computer is asking itself. Okay, if your computer tak ada translation, dia tak ada record apa Instagram punya IP address, it cannot translate, it fails. This one is basically menanya diri sendiri. So of course benda tu akan fail. Faham tak? Okay, your computer sometimes store the IP address of certain website, tapi benda alah ni is temporary because IP address biasa akan berubah. Okay, so this one failed because it is asking itself. So salah lah. Okay, now let's talk about transport layer. Transport layer is what we call a protocol, is how data is transmitted inside the internet. Okay, how do you bring one data to another, to one place, from one server to another server? Okay, so there are two famous protocol. Actually, there are two. Orang tak ada protokol lain. Okay, the TCP and UDP protocol. Okay, by the way, I'm teaching all of this from IP address, DNS server, TCP, UDP. It's important when you want to develop your own application. Okay, you want to develop your own application across more. Yeah, you need to know this kind of. In the basic. So TCP versus UDP. Okay. Oh, tak ada. Oh, truncated. Yep. Oh, guys. I think I'm going to stop here. Okay, I'm going to stop here with the presentation. So you guys can do your punya presentation on the module for GPU. Boleh? So can I give, let's take a 10-minute break. Then break and then kita start our punya GPU model. The TCP and UDP, the protocol, I can give the lecture next week. Okay. All right. See you guys in 10 minutes. And group for module 1, tolong read sedia. All right. Group 1, are you ready?
Energy level dan kita ada 4 energy level. Biasanya paling banyak 4 energy level. Untuk 3 energy level berlaku kepada Ruby, nampak ni. Kenapa dia panggil 3 energy level? Awak baca dia. Sebab daripada ground
Let's start.
Sekejap. Okay, so Assalamualaikum. So today we are going to present module 1, stopping the clock. So okay, so in this module, the objective is to accurately benchmark GPU kernel execution time and to monitor VRAM usage programmatically. Sorry, sekejap. Okay, this is important because measuring GPU performance is not as straightforward as measuring CPU's performance. So the problem in this task is GPU operation is asynchronous. So when Python program send a command to GPU, the CPU does not wait for the GPU to finish executing task. Instead, it immediately continues to the next instruction. Because of this behavior, using a standard CPU timer such as time.time bracket is only measure how long it takes to submit the to GPU, not how long the GPU actually take time to execute it. Okay, but and then the task in this module, first is differentiate two type of timing. There are two types, which are CPU timer and QDAC event timer. So CPU timer is to measure the kernel submission latency, which is very small and not representative of actual work done. And QDAC event timer measure true GPU execution, which reflect how long the GPU spent performing the computation. So the third task is to introduce the concept of asynchronous execution in GPU computing. And then the third is to use the proper tools such as QDAC event to obtain the accurate performance measurement. And lastly, monitor VRAM usage to understand the resource consumption during execution. The next.
That's for the workflow solution. First, we create two CUDA event object called start and end. These are used to mark the beginning and the end of the operation we want to measure. And then next, we record the start event by calling start.record before run the GPU operation. And this mark where the timing begins. And then we launch the GPU operations. At this time, we use matrix multiplication. At this stage, the GPU run asynchronously, meaning the CPU does not wait for it to finish. After that, we record the event using end.record right after the operation. Mark the end of the timing region. The next step is very important, which is synchronization. We call end.synchronize to make sure that CPU waits until the GPU has fully completed the operation. Once the GPU has finished, we retrieve the elapsed time using cp.cuda.get elapsed time start end, which give the execution time in millisecond. And then finally, we check the VRAM usage using memget.info, which returns free and total memory. And then from this, we calculate the used memory by subtracting free from total.
Okay, now I'm going to explain the coding. So before we write any, take our so at the first line, as you can see, we run this to check whether Google Colab detects an NVIDIA GPU. It confirms the hardware is ready. So sorry. Stop lah. Okay, sorry. So now, um, okay. So as you can see here, um, it confirms we are using a Tesla T4 GPU. It also shows the CUDA version, and then the memory usage. Here it shows 0/15360. This means our GPU has 15 gigabytes of memory, and right now, it is empty. This proves the GPU is working. And then the second line of coding, which is install QPy. We run this to install QPy. Below it, we can see the output. The system says requirement already satisfied, which means the GPU library is ready to go. We use QPy because the standard Python cannot give commands directly to a GPU. Okay, now we start to do a module one. So we import QP as CP. So this is used for GPU calculation. We bring QPy into our script and give it a short name as CP. And then we input time. So this is used to measure time using the CPU clock. So and then we bring GPU device. This line is to communicate directly with the system to ask what is the name of the GPU processing this code. It then prints the name of the GPU being used on the screen, like Tesla T4. This proves to everyone that the code is actually running on a GPU, not a regular processor. And then next, we prepare and then for the matrix size, we prepare the data. So we set a variable n to 2000. This tells the computer to create matrices up to a size of 2000 by 2000. And then we create a matrices on GPU. So here we create matrix A and matrix B. Because we use QPy, the large matrices are created directly on the GPU memory. And then as you can see in here, the float is 32. This means every single number inside is a 32-bit floating point decimal. This is the standard size for fast GPU math. Okay, and then for the CPU, okay, now we begin our first test. We want to measure how long matrix multiplication takes. So at the line 20, we use the coding. First, we start the standard Python CPU timer, and then at the line 22, we tell the GPU to multiply matrix A and matrix B, and then at line 24, we stop the timer and print the result. So here is the problem. Actually, this is not accurate for GPU timing. Why? Because the CPU and GPU work independently. The normal CPU timer only records the time it takes to send the command. It does not wait for the GPU to finish the action method. That is why the result is wrong. So, okay, so to get the correct time, we must use CUDA events. This is the main requirement of this module. So, at the line with the coding line at line 34, this creates CUDA time events. These events are designed to measure times directly on the GPU timeline. And then we start event to record, which is at line 37. We activate the marker to mark the start time. And then at the line 39, we multiply matrix A and matrix B using the GPU again. And then at line 40 and at line 41, at line 44, we mark the at time immediately after. And then at line 44, this is common max Python wait until the GPU completely finishes the math. It forces the system to freeze until the calculation is 100% done. Without this, our timer would be wrong. And then at the coding like 46, finally we calculate the exact GPU execution time in milliseconds and print it. And then VRAM monitor. Okay, for the last part, this is our code to check the GPU memory, which is called VRAM. So at line 55, this line checks the available GPU memory.
it asks the GPU how much memory is totally free and what is the maximum total capacity. So the answer will be in bytes. Okay, so at the line 57, bytes are too small to read easily. So we divide the bytes by 1024 to the power of 2. This converts the GPU memory bytes into megabytes. And then at the line 59, this is to calculate the use VRAM. We take the total memory and subtract the free memory. And then finally, we print these values. So we have successfully written the input to benchmark the execution speed and the VRAM usage. That is all for this is all for me. So I'm going to pass to the next presenter.
Uh, okay, for the output, the GPU device Tesla T4 means GPU has successfully detected, and then we get the CPU timer result. Time, as we can look, very small, and note that this is not accurate for GPU timing because CPU timer only measure how fast the task was sent to GPU. But GPU measure how long the GPU takes to complete a task. So we use Suda event timer result and we get the GPU execution time 4.0878. Means GPU execution times show how fast GPU works. Then we get the VRAM usage. VRAM usage show how much GPU memory is used. So we had total VRAM, free VRAM, and used VRAM. Sorry. Okay, so total VRAM, we get the T4 GPU memory, and then for the free, means GPU memory still available, and use VRAM means memory used on for this code. Okay.
Okay.
Okay, moving on to the last part. What are the important questions we need to check during we executing this module? Ini mic dah buka ke? Okay, first, why does CPU timer report a much faster time than the CUDA event timer? Okay, first, it is because the asynchronous execution. Okay, the CPU timer only measures the time it takes for the CPU to dispatch the instruction to the GPU because CPU immediately move to the next line of code without waiting for the computation to finish, while CUDA event timer, when we combine with synchronization, will measure the actual physical time the GPU spent executing the computation. So, the CPU timer reports a much faster time because it is only timing a quick handoff, while the CUDA timer is measuring the heavy computational workload. Okay, next. What does synchronous function actually do to the CPU thread? What will happen if we skip it? Okay, first we need to understand what is the function of this synchronous function. This synchronous function will block or pause the CPU thread from executing any further code until the GPU has completely finished all pending tasks in its queue. So that mean if we skip this command, it will break the timeline. So it will result in incorrect artificially fast timing matrix because the CPU does not wait to see how long the work actually took and causes data corruption because the CPU might try to access results that the GPU has not finished calculating yet.
Okay, next. The memGetInfo function does not return a use value. So how do you derive it from what is written? Okay, so the CPQDA runtime memGetInfo function, it returns exactly two values and it's actually in a tuple, which is free memory and total memory, and both is in bytes. So to derive the use memory, we just simply subtract the free memory from the total memory. So the formula is use VRAM equals to total VRAM minus free VRAM. So the GPU driver doesn't actively use a single score. So it uses two concrete physical states, which is the total capacity and free pointers.
So total capacity is by the physical memory chips on our graphic card. And free pointer is a list of all empty memory addresses that are currently available to accept new data. Next. If you run two different GPU operations back to back and only wrap the second one in events, would your timing include the first operation? Why or why not? So the answer is no. Our timing would not include the first operation. It will only measure the second operation. This is because the GPU, it runs on kind of like a conveyor belt because it only processes in order it was received. So for example, for operation A, it runs first, and then it will start the timer for operation B after operation A finishes. And then operation B will run, and then the timer for operation B will be recorded. So in that timeline, it will only record operations B time. And that's all from us. Thank you.
Can tengok balik the recording time. Yang result tu. Okay, this one. So you guys tengok the CPU timer result 0.11 second, but the CUDA event timer is millisecond. So of course the event timer result tu lagi cepat lah, betul tak? So a lot of time, kalau you guys tengok sini, the GPU runs very fast, but it's yang kita dapat a bit slow, 0.11 second tu. So you can see that the data is being transferred from the GPU towards the RAM semua lah. Okay, so yang synchronization tu tepat, tapi kena cepatkan lagi. I don't have any comment because you guys kind of answer all the what the module one lah. Okay, congrats. So module 2. Okay, cool.
Okay. Can everyone hear me?
Yes.
Assalamualaikum and good morning. Today we'll be presenting module 2, the PCLE bottleneck. So I will be explaining the first part of our code. First, we import three libraries, which are NumPy, CuPy, and Time. So the NumPy is used for handling the arrays and performing computations on CPU. So CuPy also similar to NumPy, but it is designed to run computation on the GPU instead. So the time module is used to measure the execution time. Next, we create the data on the CPU using NumPy. So in this line,